So, as I said, in case of slow frequency hopping system, the hopping rate will be less than or equal to the symbol rate. But in case of fast frequency hopping system, the hopping rate will be greater than the symbol rate. Means there will be multiple hops for the transmission of one symbol. Okay, so that we have verified with the 2-3 examples, right? Hope people have done and uploaded in the GCR, whatever I told you to do it. How many of you have done? Is it possible to just raise your hands? Just to get a glimpse of idea how many are. Only Akshay Kumar as Ramya, Ashwini, okay. Shreyas, fine. 4 people. Maureen, yeah. Manjunath has done. Okay. Okay, fine. So let me start today the last topic of this module, that is about CDMA system based on the IS-95. Okay. So before we discuss that, I think we need to have some basic understanding. Other than this gold sequence, PN sequence, Kasami sequence, some more sequences are used. So just I would like to throw some light upon that. I think you people can also dig more about that. Okay. Basically, this is the topic what I am going to discuss. That is CDMA system based on IS-95 standard. So in that, again, we are discussing about the forward link, reverse link, and summary of the parameters which are used in the IS-95 system. Okay. So as I said before that, you are not aware what type of codes are used in this IS-95 system, in addition to that PN sequence and other things. So let me have a discussion about that. So this is what the code, we call that as Hadamard code. Have you heard about this anywhere? Hadamard code. Hope I'm audible, na? Hello?
Yes, sir.
Yeah, I'm asking, have you heard about this Hadamard code? Okay, this Hadamard code is also known as wash code. Okay. So basically, it is an error correcting code. At least, is it possible to say from your end what are the different types of error correcting codes you have studied so far? Error correcting codes. Yes, my dear students, already you have studied one subject called information theory and coding. That entire semester, that full subject deals with coding only. Okay, so it is equally important to understand the applications of all those codes in a system. So I expect you people to share your understanding. Yes, have you studied what are the error correcting codes? There is no response only. Not studied. Yes, no ಅಂತಾನು ಹೇಳಲ್ವಲ್ಲ. Yes, no ಅನ್ನೋದಕ್ಕೂ ಕಷ್ಟ. Studied, not studied. Not studied ಅಂತ ಹೇಳಕ್ಕೆ ಕಷ್ಟನಾ? ಇದನ್ನು ಮಾತಾಡಲ್ಲ ಅಂತ. ನನಗೆ ಡೌಟ್ ಬರ್ತಾ ಇದೆ, ನನ್ನ ನೆಟ್ವರ್ಕ್ ಐತಾ? Am I with you people?
Hamming codes.
Hamming codes. Hamming codes. Okay, then. So you have studied about the Hamming codes. Fine, man. List. Okay. So as I said, this Hadamard code is known as an error correcting code. Okay, and this is named after the inventor J. Hadamard. Okay, so that is used for error detection and as well as correction when transmitting messages over very noisy or unreliable channels. Okay, hope you understood the importance of Hadamard code. Okay, it is basically an error detection and correction code, and especially this code is used right when the message has been transmitted over a very noisy or unreliable channels. So it is not used everywhere. It is used in a place where the channel is of more noisy, or when do we say that it is unreliable, only in such places this type of code is used. Okay, so in the year 1971 the code was used to transmit photos of Mars back to Earth from the NASA space probe. Okay, so this is one application, earlier application of this Hadamard code. So because of its unique mathematical properties, the Hadamard code is not only used by engineers but also intensely studied in coding theory, mathematics, and theoretical computer science. Okay, so as I said already, this Hadamard code is also known as the Wash code, Wash family. So, Wash Hadamard code in recognition of the American mathematician J.L. Wash, his name. Okay, in CDMA communication, the Hadamard code is referred to as Wash code and is used to define individual communication channels. So this sentence is important. Means how I use this Hadamard code in CDMA or in communication system is this Hadamard code I said in is referred as what wash code and is used to define the individual communication channels. Means depending upon the length of this wash code, I can say how many communication channels are there in that particular system. Okay, is that fine? So the purpose of this Hadamard code or wash code in CDMA is to what? Define the individual communication channels. Okay, so as I said, depending upon the length of the wash code, I say so many channels are available in that particular system. So it is usual in the CDMA literature to refer to code words as codes. Right? So each user will use a different code word or code to modulate their signal. And as I said, these wash code words are mathematically orthogonal. So the wash encoded signal appears as random noise to CDMA capable mobile terminal unless the terminal uses the same code word as the one used to encode the incoming signal. So it is just whatever the wash code we use at the transmitter side, the same wash code need to be used at the receiver side to get back the signal. Fine. So at least as of now, you should be able to keep in mind that wash code or this Hadamard code is referred as wash code in CDMA, and purpose of this is to define the individual communication channel. So I stress upon this, depending upon the length of the wash code, I can say how many channels this particular system can have. Okay, so just how we express this Hadamard sequence or wash code mathematically is this. So this is a simple method on how to generate a form of orthogonal wash codes. So this is one matrix H naught, right? So 1, 1, 1, minus 1. We hope you understand this. What is this? Then we define what is HK, that is channel gain matrix. So HK minus 1, HK minus 1, HK minus 1. So minus HK minus 1. Then how do we find W1, W2 and so on up to W2. So this is a generalized this one. So with one element, I get this one. So these are the two basic rules. So when W1 is this plus 1 and W2n is this formula. So Wn, 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 and this is a complement of Wn. Okay, so based on this, it will be replicated for different values of n. So when W1 is written as +1, then W2 will be, so that is when with respect to this, right, this is +1, +1, +1, and this will be complemented of Wn. So that is -1. Similarly, W4, so three matrices are replicated with this, and the fourth one is complement of that. Okay, the fourth element. That is what is written here, right? Hope you are understanding what I'm saying. Generation of different wash codes, W1, W2, and here it is shown for W4 also. This is how we make. Okay. Okay. Any generation is not there as per your syllabus. Just I'm giving additional information. Okay. At least you should know the purpose of this wash code, which is used in CDMA. If you learn extra, is also nothing wrong, na? Okay, at least you should be able to appreciate how it is replicated or generated. What is the rule? These are the two basic rules. W1 is +1, we say, then W2n is this Wn, 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 and complement of that. So, in the same way, here it is shown for three different values of n. So, this is W1, W2, and W4. Okay. Yes, hope you are able to follow what I am saying. Yeah. So now let me be specific with your syllabus. In that, as I said, now we are going to discuss about the CDMA system based on IS 95. Okay. So you all know this direct sequence CDMA has been adopted as one multiple access method for the digital cellular voice communications in North America. Okay, and this IS-95 is basically the first generation digital cellular CDMA communication system, and which was developed by Qualcomm. So Qualcomm is the pioneer in wireless, and this has been standardized and designated as IS-95 by the Telecommunications Industry Association, TIA in short we say, for use in 800 megahertz and 1900 megahertz frequency bands. Okay, so this IS-95 is basically the first generation digital cellular communication system. Okay, so which was operated in these two frequency bands. One is at 800 megahertz and another one is at 1900 megahertz. The major advantage of this CDMA over any other multiple access methods like TDMA or FDMA is that here the entire frequency band is available at each base station. What I mean to say is the frequency reuse factor is 1. Means either in case of FDMA, what happens if the bandwidth available or spectrum available is 10 megahertz, so that 10 megahertz will be divided into subbands. Say if I say 1 megahertz is subband, so I can have 10 such subbands, right? So that will be assigned to each users. Let me say with respect to this example, so 10 users can be accommodated. Okay, so that is what happening in FDMA. But in case of TDMA, what happens? All can use the same frequency, but at different timings. So there, based on the different times, people can use the same frequency. But in case of CDMA, that entire 10 megahertz can be used by everybody. Okay, and each user is differentiated by a unique code known as the pseudo noise code. Okay, with that, what I can say, the bandwidth available to every user is large when compared to either FDMA or CDMA system. That is how we say here the frequency reuse factor is 1. Hope you got understood this point. Hello, hello. ಮುಂದೆ ನಾನು ಹಲೋ ಹಲೋ ಅನ್ನೋದೇ ಇಲ್ಲ if you don't respond. Hello, can I expect any response?
Yes, sir.
What happened? 35 people, what I'm seeing. Out of 35, it takes so much of time to say yes. That one fellow only. What others are doing? Hmm? Yes, Srujan. Srujan. Bharti. Bharti.
Yes.
Dhanya. Ananta.
Yes, sir.
Can you tell the advantages of CDMA, man? Ananta. Just now you joined, I think, right?
Yes, sir.
Yeah, I could see that. I think then you will not be. Yes, Karunya. Dhanya
Yes,
did
sir.
not. Yeah, can you tell me the advantage of CDMA over any other multiple access techniques?
So it does not require any synchronization,
Hmm.
and many users
It does
can.
not require any synchronization. Huh? I did not say anything like that no, about synchronization. Are you there with me? I was giving some example. I told about FDMA, then TDMA, then I told about CDMA. Karunya. Yes, Karunya.
Yeah, sir.
What example I gave, is it possible to say? I took some numerical value. I said this is what the bandwidth is available. How that bandwidth is going to be utilized in case of FDMA system. Okay, and the same bandwidth how it is utilized in TDMA system, and in what way it is different in CDMA system. Yes, is it possible to recall and say?
I couldn't note it down, sir.
You couldn't note it down. Okay. Yes, Sagar. Sagar. What about Prithvi? Prithvi. Neeraj. Yes, Neeraj. Subiksha.
Yes, sir.
Yeah, is it possible to say what I was asking to Karunya from your end?
So can you repeat the question?
Means you are also not attentive. If you are attentive, you would have, no?
No,
Hmm?
no, sir, I couldn't hear the question properly.
I'm asking what is the advantage of CDMA over any other multiple access technique?
Sir, it enhances the performance, sir. So, um, So where multiple signals can occupy the same bandwidth, same channel.
Yeah, continue.
Yes, sir. That's all, no, sir. That's the advantage. Many signals can occupy the same channel bandwidth.
Okay, what you are saying is 100% correct, but maybe you need to tell slightly in a more professional way. Okay, fine. Thank you. At least you could answer. Okay, so as I was saying, the frequency reuse factor is 1 in case of CDMA system. Why I say frequency reuse factor is 1 is because everyone can use the entire available bandwidth in that particular area. Okay, but it is not like that in case of any other multiple access technique like FDMA or TDMA. So I gave an example. Let us assume that the 10 megahertz is the bandwidth available or allocated by the uh, concerned regulatory authority to the service provider to use the spectrum for this mobile communication. Okay, if that is if 10 megahertz is the bandwidth, let us assume that it is an just assumption. Okay, it is not with respect to what practically they are. That depends on again a different system. So I'm assuming that each user requires a bandwidth of 1 megahertz. In that case, in case of FDMA, that 10 megahertz bandwidth will be divided into 10 subbands, and each subband is having a bandwidth of 1 megahertz, right? So it is possible to accommodate only 10 users in that particular coverage area. Okay, that is the thing with respect to FDMA system. And in case of TDMA system, what I said, every user can use the same frequency, but at different time intervals. Okay, so with that, I said that there are 10 subbands, right? So maybe on each subband frequency, so depending upon the frame structure, so let us assume that 8 users can be accommodated over one particular this one. Means all the 8 users can use the same frequency, but they talk at different time intervals. So that is how we say at least capacity of the system increased when compared to FDMA, but still it is limited. But in case of CDMA, what happens? The entire 10 megahertz can be used by each user, right? With that, the bandwidth available to each user is very large, and each user is restricted, means differentiated by the use of PN sequence. Okay, so with that, it is possible to accommodate more number of users also, and each user will get the more bandwidth. That is what the beauty of this CDMA system. Okay, so I said the bandwidth used for transmission from base station to the mobile receiver, we call that as a forward link, is of 1.25 megahertz. And similarly, uh, from mobile to base station, another 1.25 megahertz is used. Okay, fine. So that we call it as a reverse link. So if I say forward link and reverse link, you should be able to visualize. Forward link means it is the signal transmission from base station to the mobile receiver. Okay, reverse link means it is the signal transmission from mobile transmitter to the base station receiver. Okay, so it requires a bandwidth of 1.25 megahertz for forward link and as well as the reverse link. So the signals which are transmitted in both the forward and reverse links are direct sequence spectrum signals, and they have a chip rate of 1.2288 into 10 power 6 chips per second. Okay, so this is what the chip rate means. That is equal to TC, T suffix C, right? That is how we represent the chip rate. So which is equal to how much? 1.2288 megachips per second. If you take 1 over that, you will come to know what is the chip frequency. Fine. So just to get a better visualization, I have shown with respect to with the diagram what is forward link and what is reverse link. Hope you will all be very clear with this. I said the signal which is transmitted from base station to the mobile is known as the forward link, and similarly the signal which is transmitted from your mobile to the base station is known as the reverse link. Okay, each link requires a bandwidth of 1.25 megahertz in case of this IS-95 system. Okay, so it will be a different, the bandwidth requirement will be different in different systems. In case of IS-95, which is 1.25 megahertz. Okay. Yes, hope this is clear.
Yes, sir.
Yeah. So now let me discuss about this forward link and as well as the reverse link. Okay. So this IS-95 has been adopted in North America initially, which is proposed by Qualcomm. Okay. As I said already, this has been standardized as IS-95 by the Telecommunication Industry Association for use in 800 megahertz and as well as 1900 megahertz frequency bands. So you should be very clear about this. What frequency band, in what frequency band this IS-95 has been operated. One frequency is what? 800 megahertz and another frequency is 1900 megahertz. Okay. And I said base station to mobile, that link is known as forward link, right? And that forward link is also known as the downlink. Okay. And from mobile station to base station, we call that as reverse link. It is also known as uplink. Okay, uplink and downlink. So these are the most widely used terms. Okay. Uplink means it is the signal transmission from your mobile station to base station. So downlink means it is the transmission of the signal from base station to the mobile station. Okay. As I said, with a channel bandwidth of 1.25 megahertz. And I said both the links, that is uplink and downlink, are direct sequence spread spectrum or direct sequence spread spectrum signal with a chip rate of 1.2288 megachips per second. Okay, so before I take up this theory, what I've written here, so first let me show the block diagram of this forward link. Then we will come back to this theoretical this one. So this is what the block diagram of IS-95 forward link. Just I will give 2 minutes time, 2 minutes or 3 minutes. Just have a look. Everyone, I may ask randomly any one of you to say what is each block is. Hope people are able to see. Yes, good to see. Hello.
Yes, sir.
Yeah, I want other people to respond.
Yes, sir.
Yes, I said other people to respond. Is it seen? You could see all the blocks.
Yes, sir.
Yes, sir.
Yes, other people means only other two people have done, Ramya and Karunya. So what I find strength is around 40 plus. What remaining 37 people are doing. And some have not at all responding.
Yes, sir.
Yes,
Yes,
sir.
sir.
So we can see, sir.
Confused, eh?
No, sir.
Don't have to be confused. It is simple to understand. Just have a look from maybe two inputs are there. Okay, what is the first input, which is the of a different data rate? One starts with 9.6, right? Like that, then that at least one particular sequence. Okay, just yeah, at least looking at this diagram, do you feel that you know something about this? At least some part of this. Is it possible to say, or you are totally new to this? Yes. Looking at this block diagram, is it possible to say that you have some already studied some blocks and you are using those blocks here? You have some idea about some concepts. So with that, let me try to understand how this actually IS-95 downlink has been designed. It is just block diagram approach, okay? So every block is having its own complexity. Yes, I would like to get the response from your end. Yes, at least it is not that everything is new, right? You know. Is it possible to say what are all the things you know? At least looking at the blocks. Yes, I expect response from different people. At least so many blocks are there. At least I expect some 5 to 10 people can respond with this.
So carrier signal generator.
Okay, very good.
Phase
Carrier generator means that structure you are aware already, right? In phase and quadrature phase.
Yes.
I expect you people to say in that way. Means
Okay.
you have seen in that way, right? So whatever the incoming signal is coming, that you are going to split it into two channels, in phase and quadrature. And I hope you know why we do that in phase and quadrature phase. Why we express the bandpass signal in terms of that canonical, this one, right? Hope got that point? Then anybody else, anything else? Only that much, what Shreyas has said. Then rest of the things you are not aware?
Pseudo noise generator.
Yeah, PN generator in this semester only, just 2 days back we have discussed it, right? So PN code sequence generation, you know. Okay, very good. Then,
The baseband filter.
very good. Baseband filters, you are aware. Fine. Yes, what else is known? Why you are not aware of convolutional encoder? Yes, you are not studied convolutional coding. I am not getting any response. Convolutional coding or convolutional encoder. Yes, not studied in ITC. convolutional codes. So I'm not asking you, I will not ask you people to explain. At least you confirm that you have studied or not studied. Convolutional codes.
Studied, sir.
Studied, no? Why, Navrin, you are only taking so much of time? Hmm? How can I expect a quick answer from others? Yeah, only Navrin is telling convolutional coder or encoder is studied. What about others? Not touched that part?
We have, sir.
Okay. Okay. Okay, no issue. I will not ask you people to take the sequence and tell me how does it do the coding by using convolutional. At least you should be able to recall. If not, go back and so that is what it requires the knowledge of even previous semesters subjects, whatever you have studied so far, and even present semester also. Fine. So with this understanding, though since it is a block diagram approach, no, if you practice about this block diagram, then explanation can be done by yourself. Okay, only thing is you should know the flow. Okay, so whatever we speak, right, it is a voice signal that has been converted into digital signal by using uh, what is it possible to say? Anyone of you? Speech coders are there. Are you aware of that? Speech coders. Speech coders. I'm asking. Not aware. Okay. If see PCM you have studied, na? I have only thought. I think you cannot say no. PCM I have thought. At least you are aware of that.
Yes, sir.
Yeah, it is basically analog to digital converter, right? PCM. How we convert analog signal into a digital one. So, like that, there are voice, means coding techniques. Okay. Uh, so there are different voice coding techniques. In that, here the type of voice or speech coder used is the code excited linear predictive coder, that is CELP we say. Okay, I repeat once again, code excited linear predictive is the type of speech coder used here to convert the speech into the data, digital data. Okay, so here, so the different data rates what I'm shown here. One is 9.6 kbps, second one is 4.8 kbps, next one is 2.4 kbps, and last one is 1.2 kbps. So these are the different data rates which can be obtained by the speech coder. I said the type of speech coder used is what? Code excited linear predictive, CELP coder. Okay, so that is the first step. Your speech has been converted into a digital data. Okay, so how do we do that here? So it will be generating a data at variable rates. What I said is one is 9600 bps, another one is 4800 bits per second, next one is 2400 bits per second, and last one is 1200 bits per second. So in short, what we say, 9.6 kbps, 4.8 kbps, 2.4 kbps, and 1.2 kbps. Okay, so here the data rate is a function of the user's speech activity in frame intervals of 20 milliseconds. Okay, means the user's speech has been, that user's speech activity has been divided into frame intervals, and that duration is of 20 milliseconds. Means every 20 millisecond speech signal has been sampled and quantized, and it has been converted into the digital data. So with that, we are able to get these are the different data rates from the speech coder output. So that has been passed through this convolutional encoder. Okay, So with a coding rate of 1/2 and the constraint length of this convolutional coder is 9. Okay, the constraint length we denote usually by capital L, which is equal to 9. Okay, means the input to the convolutional encoder is a variable data. Okay, I said what is it variable data? I get 9.6 kbps, 4.8 kbps, 2.4 kbps, and 1.2 kbps. But the output of this convolutional encoder is maintained at 19.2 kbps. Means here I said the coding rate is 1/2 and the constraint length of the convolutional encoder is what's 9 I said. And here means for 9.6 kbps that is fine. For the lower data rates for 4.8 or 2.4 or 1.2 kbps, means that data rate has been multiplied by this coding rate to get the output of this convolutional encoder as 19.2 kbps. Means for 4.8 kbps it will be multiplied by 2. Okay, for 2.4 it will be multiplied by 4. For 1.2 it will be multiplied by 8. So 1.2 into 8 is 9.6, right? 2.4 into 4 it will be 9.6. Then 4.8 into 2 it will be 9.6, right? So that is why we say the convolutional encoder with a code rate of 1/2 and constraint length of 9 is used to maintain a constant data rate of 19.2 kbps at the output of the convolutional encoder. Then after that, the next one is, we say it is a block interleaver. Okay, here it is written block interleaver, right? So the purpose of this block interleaver is to okay, as I said, the purpose of this block interleaver is to overcome the effects of burst errors. Okay, so that may happen or occur during the transmission through the channel. Okay, so, I think this interleaving, how the blocks has been interleaved and all, let me explain that. Means, as I said, the output of the convolutional encoder is maintained at what? 19.2 kbps, right? So which is at constant rate. So the encoded bits for each frame are passed through this block interleaver. Okay, this, as I said, this block interleaver will overcome the effects of the burst errors that may occur in transmission through the channel. Okay, so the data bits at the output of the block interleaver will be of what value? It is of 19.2 kbps only. So that will be scrambled by multiplying with the output of the long code generator. So it is the PN sequence generator it is again. So here the period of this long code, which is equal to what? 2 power 42 minus 1. Okay, here the value of n is equal to 2 power 42 minus 1. Okay, so that will be that long code generator will be running at the rate of this 1.2288 mega chips per second. So that is the chip rate of this PN sequence generator. Then it will be decimated. Okay, that is why your block is the decimator. So this decimator will be taking every 64 bit, and it provides a data rate of 19.2 kilosymbols per second. Okay, so that will be scrambled with 19.2 kbps. Then it will be multiplied with the wash code. Okay, here the wash code is having a length of 64, means I will be able to have 64 different channels. As I said, no, the purpose of this wash code is to indicate the number of different channels in the Cdma system. I said the wash code length is of 64 bit, means I will be able to have 64 channels. Out of 64, okay, one channel is used as a pilot channel with all zeros, and another channel is, or another one or two channels are used for synchronization. So other than that, the rest of 61 channels are used for the purpose of transmitting the information for individual users. Okay, so I think with this we are getting here the scrambled data over a particular channel with the wash code. Then what happens? It is split into two paths. One is in phase path and another one is the quadrature path. So here we are using a PN sequence of length 2 power 15. Okay, for each of the paths, in phase and as well as quadrature path. Then further process, you know what is happening here, right? So this is how we get the CDMA signal. Okay, so I think let me say once again about this in detail with respect to what is the data rate obtained. I think I hope till this point is clear how the speech signal has been converted into variable data rate by using what speech coding technique. Then what is the type of coding rate with constant length, right? Then what is this PN sequence which is used here? Then how do we do that scrambling? Then how it is transmitted over a particular channel, right? Then splitting into in phase and quadrature, and what is the length of the PN sequence we use at each of the channels. I think you will be able to understand by yourself about this block diagram. Okay, so I think let me stop with this. I think if I take 1 more hour, I will be able to complete this. Is that fine?
Yes, sir.
So just now I
Yes,
given
sir.
from this one. No? You also can have a look